Good afternoon, good morning, good evening, whenever you're watching this. Transformation of functions, the last part of chapter 2, the last section in chapter 2. What's unusual about this is that it's almost like the author doesn't realize that we have access to a TI 83 or 84 calculator, which basically can graph the function that we're provided with. The only way that this would kind of make sense is if I gave you an exam in class and didn't allow you to use your calculator. Then you would have to obviously realize what some of these basic functions look like: the line, the parabola, square root function, the cubing function, the S shape, kind of an S shape, but kind of on its side, the reciprocal function 1 over x, and then the absolute value, which is easy to recognize because it's the V-shaped. So watching the transformation video, you saw how different numbers affect the graph. The minus sign, obviously, flipping the graph upside down. If this coefficient is a number that is bigger than 1, what it does, it stretches the graph. Sort of stretches it, makes it taller and skinnier. This number here, which is inside of the parenthesis, what's happening to the x is also happening to this minus 2. In this case, it's being squared. This is a horizontal movement. Now, you may think that the minus moves the graph units to the left, because if it's a minus, but in actuality, it moves it to the right 2 units. This number outside here, if it's a minus, it moves the graph 2 units, well, moves it down. In this case, moves it down 2 units. And if it's a plus, it moves it up. This one here is in reverse order. A minus horizontal movement means move it to the right, and a plus would move it to the left. This is exactly what you see. Subtract 2 means move it down 2. All right, let's take a look at these. First thing I notice is that I've got it's a square function, so it's a parabola. And the 6 is not inside of this parenthesis. It's not being affected. What's happening to the x is not happening to the 6. So this is a this is a vertical movement. It's a minus 6. It's taking a basic parabola and moving it down 6. Well, obviously, this is not a parabola. It's the absolute value. This guy's been flipped up. This guy here, this is a parabola, but it moved 6 units to the left. This is the guy I'm looking for. It took a basic parabola, which had a vertex right there, and moved it down 6 units. But, the idea is you've got a calculator. All you would have to do is put this into your calculator, y equals, and then hit graph and then match up the graph that's on your calculator with letter D. So you don't really have to know transformations. And kind of wondering why I even assigned this, but these would be real easy questions for you to answer because you got your calculator. Number 2 is the absolute value function. Notice what's happening to the x is happening to the 2. It's right inside of this absolute value function. So whatever is happening to the x is happening. So this represents a horizontal movement. Minus, you would think, moves that V shape to the left. It actually moves it to the right 2 units. That's what's happened here. All right, vertex was here, and this is not working so great, so let me erase that. The vertex was right at 0, 0. It moved that whole graph 2 units to the right. All right, so let's see here. Number 3, you've got the absolute value function, but you got a negative sign. First thing I notice with a negative sign, it's going to be flipped upside down. 4 means it's going to be stretched. All right, so it's going to be taller, and it's going to be sort of skinnier, I guess I would say. And the one that's been flipped upside down is C and B, but C is not the absolute value function. This is a parabola. The absolute value function is the V shape, so it's been flipped upside down and been stretched. It's taller. I should say it's taller. It's skinnier and narrower. I'll say it that way. Obviously, this guy here is it's just been stretched. It's an absolute value, and this guy's a line. So, and once again, you could put this into your calculator, and it would have given you the correct graph. So, number 4, you've got a horizontal movement 3 units to the right in the positive direction, just the opposite of the minus. And the graph has been moved down 4 units. So as you can see, this guy got shifted over 3 units to the right, and got shifted down 4 units. This one went the opposite way. It went to the left in 4. You want it to the right in 4, just the opposite. Minus moves it to the right. I'm not sure. This guy's an absolute value, and this guy got moved 3 to the right and moved 3 down. Let's see what's going on there. Pretty much everything is happening in number 5. You got a negative, which means it's flipped upside down. You got a half, which means instead of stretching it, if this value out front is between 0 and 1, it makes it shorter and stubbier, chubbier. It depresses it, squeezes it. The 3 means positive 3 is a horizontal shift. It went 3 units to the left and then 2 units up. So all of that being said, you can see letter D, but once again, put that into your calculator. And the same would be for number 6, without me even explaining it. It's just difficult, in a video. What I'm going to say is just put this bad boy into your calculator. Now, whether you use a half or use 0.5, she'll pop up as letter B. It's been compressed. It got moved 5 units to the left and then 4 units down. So you can see here, this is a left movement. This is a compression. All right, you got squeezed. Then the absolute value, the V shape, got moved 5 units to the left, and then a -4 means it got shifted down 4 units. Number 7, it's a parabola. I'm sorry, it's a cube. It's an S shaped. All right, the +2 means it got shifted 2 units, not to the right, but to the left. But once again, you put that into your calculator, it's going to come up with letter B. If you ever have a situation where you have two that look very much the same, what I would do is pop a number in for X. All right. Put a value like 1 or 2 or 3, and then look at the two that you're considering. You'll know, for instance, if I put a 2 in here, 2 plus 2, or put a 1 in there, 1 plus 2 is 3. 3 cubed is 27. So when X is 1, your value should be 27. You see here, if X is 1, my value of X is way off the chart here, 27. So if you have any discrepancy, you're debating between 1 or 2 different answers. Plug a number for X, and then look at your graph and see if the graph actually gives you back that number you put in for X. That's a way of cube root. All right, basic cube root function. It's been shifted up 4 units. So there it is. There's your basic cube, which look like going to the origin, but it got moved up, in this case, 4 units. What else have we got here? Number 9, what's happening to the X is happening to the 1. So this represents a horizontal shift. It's a +1, so it goes in the opposite direction. It goes 1 to the left. You can see originally the graph started out at 0, 0, but 1 to the left. Now it's at -1, 0. And your calculator would do that. Here you got a horizontal shift of +7 and a vertical shift of -1. So 7 to the right, the basic cube function went 7 to the right, 7 to the right, and it got shifted up, well, shifted down, excuse me. So minus here, so it got shifted down 1. So again, your calculator would handle all that. So that's the scoop with transformations. Just put it, you won't see many on the test, maybe 1 or 2. It's like it's freebie. Y equals graph it. There it is. All right.